Okay, so this is the first video looking at Chapter 6, our final chapter in the data analysis module. And this chapter is all about time series data. So time series data is a special subset of bivariate data. So we've been dealing with bivariate data, so data where we have two variables for the last couple of chapters, chapters 3, 4 and 5. But in this case, it's a special case where the explanatory variable is time. So if the explanatory variable is time, whether that's seconds, minutes, hours, days, weeks, months, seasons, quarters, years, whatever, it is time series data. So for example, if a company were to record its sale figures over a 10-day period, this would be an example of time series data, and we could create a time series plot, which is essentially just a scatter plot, except that we join the points with a line. And doing this enables us to better see trends and patterns and fluctuations, but also want to be clear about why we don't generally join a scatter plot with a line, and that's because in a scatter plot we could, for example, have data, just let me get a slightly thicker pen here. We could, for example, have data on day 3. There could be day 3. If it's not sales, we're recording something else. We might have 3 different values happening on day 3. And then on day 7, we could also have, and 2 values happening on day 7. And so then if you were to think about joining up the plot, well, okay, day 1, you join that to day 2, but then you're going to join that to day 3. Well, which of day 3's points do you join that to first? Do you draw a graph that does this? Okay, or do you draw a graph that does this? And does that say something different? And does it actually mean anything, the shape of that? And it doesn't. So the reason that's why we haven't joined the points beforehand. It's actually really relevant to do so. But the fact that in time series data, we have 1 point for each day, then joining them up is telling us, showing us the pattern of what is happening from day to day. Okay, and we're getting a sense of, is it going up, is it going down, is it fluctuating a lot, etc., etc. So whenever you draw a time series plot, it's just a scatter plot, but you must join up the dots. Okay, so a couple of things we're looking for, when we're looking at our scatter plot, time series plot, is trend. The first thing we're looking for is trend. So in considering the trend, we're looking for long-term upward or downward movement in the time series. Okay, so obviously it'll go up and down, there'll be fluctuations and all sorts of things. But over time, is the time series plot going up, or over time is the time series plot going down? Okay, so a trend line is relevant here, and the trend line is just the line of best fit. So if you, and the line of best fit is just the least squares regression line for the data. So if you draw your least squares regression line on the time series data, and it goes up as you go from left to right, then you have an upward trend or an increasing trend. If the least squares regression line goes down, its gradient is negative, then we have a downward trend or a decreasing trend. It's also possible for a time series plot to display more than one trend over different time periods. So if you've got quite a lot of data, you've got data on something for the last 100 years, you're going to see different trends at different times, and they might associate with different political events or different things going on in society. Sometimes it's not necessarily practical or sensible to look at the overall trend over the entire time period if you've got a very long time period, and instead you would look at certain sections. We'll look, between 1930 and 1960 there was an upward trend in the birth rate, and then from just before 1960 until the early 70s there was quite a steep downward trend in the birth rate, and then you might look for reasons. Well, that might coincide with the introduction of birth control and all sorts of things. And then trend 3, we still have a downward trend, but at a much slower rate from 1970 to the 1990s. And again, you can then make some inferences from that based on what's going on in the time. But it doesn't make sense if you were to fit a trend line or a least squares regression line to this data, so a line of best fit to this data, it might go, I don't even know what the content library is, go away. it might go somewhere like this, and it doesn't actually fit any of the data very well. It's an overall downward trend, but it's not really telling us anything. So sometimes it makes more sense to split things up. And again, we're talking about situations where we have a lot of data over a long period of time. Realistically, you're going to be looking at fairly small data sets because we're not going to be asking you to spend hours entering a data set into your CAS, and therefore we're probably not going to see these examples with multiple trends within the one plot. Okay, so the first thing we're looking for in our time series plot is trend. Is it going up over time, down over time, or is there no clear trend? Then we're looking at fluctuations, and there's a number of different fluctuations we might see. Now, generally speaking, in a time series plot, there is always going to be fluctuations, okay? Whether those fluctuations are regular or irregular is one of the things we want to try and look for. So the first thing is we could have cyclic or seasonal fluctuations, and this is where there's a regularity to the fluctuation. It doesn't need to be exactly the same, but there's a sort of pattern to the fluctuation. Particularly, we're talking about seasonal fluctuations if those patterns follow some sort of calendar. Whether over a 24-hour period they follow the same pattern every 24 hours, whether over the course of a week they follow the same pattern every week, you know, higher on a Monday, lower on a Wednesday, whatever it might be, okay? Whether over the course of a month they follow the same sort of pattern. Early in the month, numbers are high and then they drop off as the month goes on, or whatever it might be, okay? And you're seeing that repeated from month to month. You'd be looking at seasonal fluctuations. You might see things happen literally seasonally, you know, so quarterly, so coinciding with the seasons, spring, summer, autumn, winter. You might see things happening monthly. You might see things happening annually, okay? We can also have cyclic patterns, and that would be where there are patterns, but they're not tied to a clear calendar pattern. Okay, so they're not days, weeks, months, years. Okay, generally speaking, cyclic patterns, they might not be of a fixed period. So, for example, you might see one cycle happen over the first 5 years, and then the same cycle repeats, but stretches out over to the next 8 years. But you're seeing cycles of sales or whatever your data's about happening. The other thing is that cyclic patterns, the fluctuations are generally of at least 2 years duration. So anything less than that is generally going to be described as a seasonal fluctuation. So if it's happening within a year or within a week or within a month, we'd still probably call that a seasonal fluctuation. We're generally looking at quite long-term patterns that we might describe as cyclical. Okay, so let's have a look at some plots here. So the first plot where we're looking at time and houses sold over a 3-year period, we're seeing an increasing trend. We're also seeing fluctuations, but we can note that those fluctuations aren't irregular. They're actually seasonal in that we're getting a trough in the second quarter and a peak in the third quarter every year. Okay. The difference between the peaks and the troughs varies from year to year. It's not exactly the same shape, but that sense that sales drop in the second quarter and they increase again in the third quarter before slowly dropping through the fourth and first quarters again into the next second quarter. The fact that we're seeing that regular pattern is seasonal fluctuations. So, as I said here, seasonal fluctuations don't have to be associated with summer, autumn, winter, spring. It doesn't mean seasons, just any period of time defined by the calendar. So, for example, if we had daily fast food sales, we might find that they're higher on Friday and Saturday nights and lower early on in the week. And so the fact that we've got a regular pattern connected to days of the week suggests seasonal fluctuations. So patterns associated with season, quarter, month, day, hour even, would all be considered seasonal fluctuations. Cyclic fluctuations, on the other hand, fluctuate in cycles that don't adhere to the calendar. The cycle periods are usually irregular, and as I said, they're usually longer than 2 years. If we're looking at something that happens every month or every time period less than 2 years, we're probably looking at seasonal fluctuation. So these are quite long-term fluctuations. So the graph opposite shows the number of sunspots visible over the last 100 or so years. So that's a lot of time, and we're seeing that there's clearly a cyclical pattern here. It really regularly over those 100 years goes up and then down and then up and then down and then up and then down. There is definitely a cyclical pattern here. But the period between, sorry, that shouldn't say weeks, the period between peaks in the data is approximately 11 years. So it's a regular cycle but not a seasonal one. Okay, cycles can also have less regularity but still be cyclical. So for example, if we're looking at software sales, we might find that the software sales, when we release a piece of software, the sales might be slow at first, and then they might sort of peak shortly after as word gets out and the software becomes popular, and we might get a peak and a rush and good solid sales, and then things will slowly drop. Sales of that software will drop off as that software becomes older and older and older. Then when we release a new piece of software, we trigger that cycle again. Okay, so that cycle might not happen. You might release software. You might have a regular cycle to software release. It might happen every year, in which case you might then call that seasonal as well. But you might also release software on a really irregular cycle, and therefore there's definitely a cycle. It's being triggered by something, but it's not a calendar related something that's triggering it. So those are regular fluctuations, seasonal or cyclic fluctuations. Then we can have irregular fluctuations. Now I want to be really clear that every single time series plot has irregular fluctuations. In fact, even these seasonal and cyclical fluctuations, there's some irregularity here. We're not seeing exactly the same cycle happen from month to month or year to year. Okay, so all time series plots have irregular fluctuations. I want to be clear about that. So they might be completely random fluctuations. They might be associated with the fact that there's an outlier in the data. And as we know, outliers really skew things when we're trying to fit lines of best fit and trend lines, so we might look at removing that outlier. Or fluctuations could be a result of structural change. So that is some sort of societal or outside influence that caused the change. So for example, the plot we're seeing here is electricity use in a particular apartment on a monthly basis, and we see that from January to June, okay, there's irregular fluctuations there, but it's sort of steadily about $250 to $300 a month, and then all of a sudden after June there's a steep drop, and then we get a fairly steady pattern after that from July to December where the electricity use is about, sorry, it's not dollars, it's kilowatts, kilowatt hours, so it's about 150 to 200 kilowatt hours every month. And so there's probably something going on there. It may be that the tenant in the apartment or house changed, so different people are using the electricity differently. It may be that they changed electricity supplier, although that wouldn't change their use. It may be that they installed a whole lot of energy efficient appliances and better insulation and all sorts of things, and they cut their electricity bills. Perhaps they installed some solar panels and they're using less from the grid, from whatever's measuring this, whatever it might be. There's something that has created a significant change at a particular moment. I don't want you to stress too much about this. You really want to be looking for whether you've got regular fluctuation or irregular fluctuation. Okay, so whether the fluctuation is seasonal or cyclical, or whether it is just purely irregular. But there will always be some sort of fluctuation in a time series plot. We'll look at down the track, obviously fluctuation potentially creates problems with fitting a line of best fit, and we'll have a look at ways of moderating for that over the course of this chapter. Okay, so for each of the following time series plots, comment on any trend, so upward, downward, or no clear trend, and any features observed. Okay, so the first plot, I would say we have an upward trend. If we were to sort of think about a line of best fit, somewhere sort of here, we have an upward trend, and then we've got some irregular fluctuations, or we might even say, I might even say that that's possibly an outlier. Upward trend with irregular fluctuations, and even if we ignore the outlier, there's still irregular fluctuations because the points don't follow a perfect line. There is fluctuation. So as I said, there'll always be fluctuation with irregular fluctuations and a possible outlier. Okay, B. We're looking for trend. So again, I'm seeing pretty clear upward trend here. We're also seeing, I would say, a repeating pattern here. So up quite a lot in the first year, up a bit less in the next year, and then a dip in the fourth year. Okay, up, and then a dip, up, and then a dip. Okay, so I'd say we've probably got, and it is happening every 4 years, so I'd probably say we've probably got seasonal fluctuation there. Okay. So we've got upward trend following a nice clear calendar pattern, upward trend with seasonal fluctuations, because it's more than 2 years, you might also describe them as cyclical fluctuations rather than seasonal. I'm happy to be a bit flexible about that. People sort of get a bit stressed about this, but honestly, it will be pretty clear which of the two we're looking at. I'm going to write seasonal or cyclical. I'd be happy with either in this case, because there is regularity to that period, but the fact that it's a longer than 2 year period, we probably call it cyclical. Upward trend with seasonal or cyclical fluctuations, and there is also irregular fluctuations, but because it's not following the exact same cycle every 4 years. But yeah, let's focus on the main fluctuations there, which are the seasonal or cyclical. The second one here, we've got, again, upward trend, definitely. Sorry. Upward trend. And then I'd say there's not really much pattern to what's happening there. I'd say we probably just have irregular fluctuations happening there. There's no really clear outlier, so I don't think it's that, it's just irregular fluctuations. Now in part D, we've got a clear seasonal pattern happening here. Okay, every year we're seeing the same pattern happen with an overall upward trend. Could have given you an example with a downward trend, couldn't I? Upward trend with seasonal fluctuation. Yeah, I think we might change B. I think we might go with cyclical. Every 4 years, longer than a 2 year period, we'll go with cyclical fluctuations there. Upward trend with seasonal fluctuations. Okay, and then part E, the following time series plot shows the daily cost of running a manufacturing process. Okay, so what we're seeing here is really two separate trends. Now I would say for the first 16 or so days, there's not really much of a clear trend, maybe slightly upward, but without fitting the line of best fit, we can't really say that. And then we get a significant structural change happening at around day 16, and then we're getting a slight downward trend after that. We've probably got irregular fluctuation throughout. There may well be, there's possibly a bit of, cyclical. The first portion looks like there's a fairly clear pattern there in terms of down and then up and then down and then up. But it's hard from the scale to tell whether that's happening on a regular sort of time period. And yeah, in the second half of the data, there's more irregular fluctuation. There's less clear pattern to that. So I would probably say that for the first 16 days, we see no clear trend. And irregular, possibly cyclical. The scale's not really clear enough for us to see that. Fluctuations. There is a structural change, at day 16, or around about day 16. And then from day 16 to 31, there is a slight downward trend. With irregular fluctuations. Okay, so just thinking about trend, upward or downward or no trend, and fluctuations. Are they regular? Are they seasonal or cyclical? Or are they irregular? And then there's a few extra things sort of like structural change. So constructing a time series plot with your CAS, let's have a look at doing that. It's exactly the same as just a scatter plot, except that we add in one extra step to join the points with the line. Okay, so here's our data set. So you want to enter that data set into your CAS. You might want to pause the video while you do that. I've already done it. So what you'll notice here is that when your time variable is categorical, essentially, which is what ours is here, Monday, Tuesday, Wednesday, Thursday, Friday. Strictly speaking, we can't draw a scatter plot with a categorical variable, so we need to create a sort of time series coding in that I'm going to call Monday of week 1, day 1, I'm going to call Tuesday of week 1, day 2, Wednesday of week 1, day 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, sorry, 34, 13, 14. Okay, so you need to create a time code if your time variable is categorical. Okay, so obviously just we've got days 1 to 14 happening here. So I've entered in the days as the first variable, and then the viewers, so this is number of people in millions who watch Channel 9 over a fortnight. Okay, so we've got the day number and the viewers in millions. Okay, all right, so then if we have a look at the scatter plot of this, so let's insert a data and statistics page. Let's put our days on the horizontal axis. So time series, the explanatory variable will always be time. Horizontal axis is always time. Okay, and then we are looking at the viewers. Right, so this is a really clear example of why we actually join the plot with a line, because this potentially looks quite random. It's actually really hard to see the patterns happening here just with this plot. So you want to join with a line. So what you need to do is, and that's, I'm going to just scroll up here so you can see this box up here. So we want to have a look at step 5. Okay, that's where we're getting new information here. Otherwise, we're just plotting a scatter plot as usual. So you want to move the cursor to the main graph area. So I mean this white area, okay, not the grey area. You need to be somewhere in the white area. And then I'm going to do a right click with my mouse, but you're going to press Control Menu while you've got your cursor hovering somewhere in this white area. Control Menu is a right click. And then you want to go Connect Data Points. Okay, and now we have a time series plot rather than a scatter plot. So, example 2, we've got the data here. Use our CAS to create the time series plot and comment on any trend or features observed in the data. Okay, it's pretty hard to observe any trend. If we have a look at the sort of start of the week, in the second week the numbers are slightly higher at the start of the week, but then the trough is lower in the second week than it is in the first week. I would say without more data, only 2 weeks of data is quite hard to identify trends, and it can be quite hard to identify whether or not you actually have a pattern, given you're only seeing the pattern repeat twice. But as I said, we're sort of a bit limited by the fact we're not going to ask you to enter 5 weeks worth of data in just so we can identify what's happening. So I would say here that there's no clear trend from the data that we're seeing. Might be a slight downward trend, but it's really not possible to say that from just looking at this, I don't think. You might want to, as I said, if you fit the trend line, which is just the line of best fit, you should be able to see the slope of that. So if we did analyze regression and show our linear regression, okay, we actually do see a fairly clear downward trend from the regression line. Although if you look at the actual slope value there, it's negative 0.01 or 0.02 technically. So it's a very small slope. Having a look at your Y scale there, it's really not a big scale. So actually there's not a lot of variation. I'd say no clear trend. Oops, sorry, hard to write in a highlighter. I'd say no clear trend. It's possibly a downward trend. But as I said, I think the scale of this scatter plot's a bit misleading, given looking at the size of that gradient. That gradient's pretty close to 0, so it's not really going down very much. Possibly slight downward trend, but I would argue no clear trend. And then thinking about the fluctuations we've got there, we've got fairly clear fluctuations, and if we look at the data itself, we can also see those fluctuations with the viewership reasonably high early in the week, fairly steady and fairly high early in the week, Monday, Tuesday, Wednesday, Thursday, and then we see a drop off in the viewership on Friday and Saturday nights, or Fridays and Saturdays, it doesn't specify nights, sorry, and then it sort of creeps up a little bit on Sunday again. Okay, so I would say that we're seeing a pretty clear seasonal trend there, seasonal fluctuations happening there every week. Monday, Tuesday, Wednesday, Thursday, quite high, drop in viewers on Friday and Saturday, and then coming back up again on Sunday. Okay, so we've got no clear trend with seasonal fluctuations. High viewership, Monday through Thursday, fewer viewers on Friday and Saturday, and then number of viewers increasing on Sunday. Probably don't need the description in the brackets. No clear trend with seasonal fluctuations is the clear information there. Okay, so we're looking here at exercise 6A.